So name, job title, and position. Hi, I'm Pascal. I'm a researcher here at the Quantum Materials Group at the University of Oxford, where I'm a physicist to do experimental research. What is a quantum material? A quantum material is a material that cannot be described by the usual terms of physics, which we believe that our world works in on a broader scale. So something that becomes very, very small, something that acts on a very short time scale, or something that is not very deterministic, but where you need to take the randomness of nature into account. Can you summarize your research in one sentence? The single sentence that I give at conferences would be, I look into strongly correlated electron systems under extreme conditions. In a different way, I look at very strange materials when I put them under extreme pressures, at low temperatures, and very large magnetic fields. What is the best part of your job? The best part of my job certainly is that I can do what I wanted to do since I was maybe your age, maybe mid-teenagers. I can do research, I can pick the topics and the materials and the methods that I want to use, and I can study that part of nature that fascinates me the most, that part which we actually understand the least. How did you get to where you are now? It's a bit of a longer story. I did my first part of studies in Germany, actually, before I then moved to do my master's in the UK, and Oxford is actually my second position within the UK as a now more independent researcher. What one invention or discovery would you like to see in your lifetime? So I work in the field of condensed matter physics, and what condensed matter physics is certainly lacking, and it's particularly lacking when you compare it to other fields of physics, is a consistent theory that can describe the materials and the methods we use on a rather accurate level. So there are, you probably heard about some of the models which other parts of physics use, like the standard model in particle physics. You might have heard of the Higgs particle. None of that things do exist in our materials. So we're really in an explorative field at the moment. We really push the boundaries. We try to find new things. And the hope really is that by putting all those small pieces together, eventually someone looks at the large picture and realizes the patterns and comes up with a brilliant idea how this can all be summarized into a simple and consistent picture. And that is something I'd like to see. You may have heard about high temperature superconductivity, obviously, so when a material becomes zero resistive at lowest temperatures, that's just part of it, but the field is actually much, much bigger. And to see such an entire picture, that would be something very nice.